to constrain that to the midpoint by the dimensions that I use later on. I could have used a midpoint, and it would have, in that case, I would not have had to have used a dimension. So again, we talked about a little bit about whether you dimension something with an actual dimension, or if you constrain it, which is just locking in that point. Two different ways. Again, it's user preference based on how you want this part to react, how you want it to behave from a dependency standpoint. So either one would be fine.
Okay, there was another question. Are these just AutoCAD solids? Can I just use AutoCAD solids instead of these special things?
They are not AutoCAD solids. They're a unique, I don't know what the best way to explain that. Jason, you actually might be able to explain that a little better than me.
Okay, these are actually their own kind of object. I mean, they're not AutoCAD solids. They're generated especially by kind of the parametric part builder, so you can't just substitute AutoCAD solids and hope to get any of the same parametric behavior as you would for the parts you're building here.
Again, the most important thing to keep in mind is that you want to use Content Builder to build your part. You want to stay in this environment. If you had AutoCAD solids or something like that, go ahead and use the block-based part of creating parts. Create it as a block-based part, and take advantage of the 3D capability that, the 3D blocks or models you already have created in AutoCAD. If you're going to do it parametrically, it needs to have additional information than just what the standard object puts on it, gives you. So this is going to do a little bit more than just the general, what a general AutoCAD solid can do for you. A lot of that is behind the scenes, so it gets a little complicated when you think about it. Best rule of thumb is just stay inside the Content Builder environment to truly build the parts. Anything else?
I think that's it for now.
All right. Hopefully I still got everybody with us. And the next thing at this point that we're going to do is we're actually going to add some connectors, and then we're actually going to dimension this part and actually get some real world dimensions onto this part. Now, by adding connections, it allows us to put this part into the model and actually connect to it. So in order to do that, I have, and I'm going to close some of these just to make it a little easier so that everybody can see for a second here. I have a connectors section here, and if I right-click on this, I can simply say Add Connection. And you'll notice what happened, and I'm going to zoom in so you guys can see this. Every place where I have a point on this, it's going to say, do you want to put a connector there? Now, logically, I'm going to have 3 connectors. I'm going to have one on the right, one on the left, and one on the branch. If you remember, I said that the order that you actually add things can help you. What I'm going to do is I tend to always add my connectors from left to right, top to bottom. And the reason I do that is because they get numbered automatically for you, and that way you always can look at your part and say, oh yeah, that was number 1, that was number 2, because it's going from left to right, top to bottom. Kind of just a rule of thumb to help you keep track of all your different connectors. So in this case, I'm going to select on this point, and you'll notice that down here it's giving me a connection number of 1. Now remember that this specific modifier that I'm adding this connector to is associated with this profile. So what it's asking me to do is to pick a dimension position. It's actually going to dimension this circle because the connector is associated with this modifier. So I'm going to click up here, and you'll see that what happened is it's defining this modifier as a dimension. So my connector, by default, is going to assume a dimension or a size right now, based on what's in here, at 3.6. D1 is going to be my connector size on that side of my T. Now, I can also go ahead and I'm going to add the connection on the other side, and you'll notice that what happens is I'm not going to get prompted for the dimension. And the reason is because the modifier is from the same profile. So if I click on here, you're going to see that all it's going to ask me for is it's got a default connector number of number 2, and it didn't ask me for that because it knows that as this dimension or if this dimension changes, all 3 of these modifiers have a relationship that's been established with this profile. So it only gets dimensioned once. And I also now need to add a connector on the end of my rectangle, on the end of the branch. So what I can do here is go back to my connections, say Add Connection. I'm going to select a connector location. My connector location is the end of the branch, and it's going to be a default number of connector 3. And it knows its profile. The modifier has a relationship with the profile. The profile is the rectangle profile up here. So it's going to ask me. It needs its height dimension, and it needs its width dimension. First one it's going to ask me for is its height dimension, and it's saying select the geometry. So when I select the geometry, I want to define my profile dimensions. So my height dimension is going to be from here to here. So I can simply just select this line to this line, select a position for the dimension, and it knows that its height now has been defined as RH3 with a default value in there based on how I drew this, which we can change. It's also asking me for my width dimension. My width dimension is from this side to this side, or this line to this line, and I'm going to just find a location for my width dimension. So now I have added 3 connections, and if I look at my part browser, you'll see that I have 3 connections. Each one of my connections has basic information right now defined about it. It knows, for example, connector 1 knows that it's round, connector 2 knows that it's round, connector 3 knows it's rectangular, and that's all because of the relationship that we established when we built those modifiers from the profiles. Okay, I'm going to stop there. Jason, how are we doing for questions?
There's a question right now. It's what about system resources? Are these parametric parts more costly kind of to the drawing than the block-based part? Is there a big difference there?
These are actually probably more efficient than a block-based part because behind the scenes of Autodesk Building Systems, these parts, remember we said that they have a unique type of they're a unique object type. That object type has been developed inside building systems to be a very efficient type of object, parametric objects. Think of AutoCAD, the more parts, the more blocks that you're putting into an AutoCAD drawing, generally your AutoCAD drawings get large. So depending on how big your block-based part is, it's going to depend on the size of that. Everything that we can have an extremely complex part in here parametrically, but it's still going to be a single part that's being driven by parameters to change the size. It's not something that's being stored in its physical size all the time. Hopefully that helps. Jason, if there's anything you have to help with that one.
I think that was very good. Another question that's come up a couple times was, why are you working in plan? Why aren't you in a 3D view?
I could work in a 3D view. And if I flip over here, I can simply add my connectors in 3D. For me, one of the things that I find with a lot of users is a 3D environment can be intimidating. 3D environments can sometimes tend to be more confusing. You'll notice when I look at my modifier here, I got a couple extra lines. It's personal preference. I tend to find working in 2D will help you understand the basics of your part. Profiles are typically, you're going to always start from 2D and work your way up to 3D. So again, personal preference, your familiarity with working in a 3D environment works the same either way, depending on which view you want to work in. Anything?
Okay, I think that's it for now. Thanks.
Okay. All right. So far what we have is, just to back up for a second here, we have created the basics of our model for shape and size. We have added our connectors. I'm just going to close out of our connectors. And the next thing now that we want to do is you'll notice one thing that I haven't mentioned, and maybe some of you have noticed down here. You'll see down here at the bottom where underneath our part browser, it says Part Family Validation Failed. As I'm building this part, there are certain things that behind the scenes is happening. In order for a part to be valid, it needs to have certain things defined for it. For example, remember we talked about the part configuration. Having a part type has to be defined in order for it to be valid. Has to have an appropriate number of connectors. In this case, that we need 3 connectors. It's a T. It requires 3 connectors to be valid. It also needs to be properly constrained and dimensioned. The part needs to almost understand. It almost is like it has a little brain of its own. It needs to understand exactly how all of the different pieces I put in there, my geometry, my profile, my modifiers, it needs to fully understand how all of those pieces, all those features interact with each other. So we need to make sure that we've established enough relationships between all of those features that this part can understand how it's supposed to maintain its shape and its form and its size. So you'll notice that down here at the bottom it's red. This is our little traffic light to say, well, you know what? Right now, without me saving this part, it's telling me that there might be something missing. Maybe I haven't completely constrained it the whole way. If I come in and I actually save my part, you'll notice that it was successfully validated. At this point, this is my way of checking. Have I constrained? Have I added dimensions? Have I added enough of information to this part to define the basic shape? Yes, I have. If I hadn't, it would give me basically a dialog box that would say you're under constrained, you're missing a dimension or something because those relationships haven't been built yet. So I can simply say yes. My traffic light turns green, so it says it's successfully validated. And that at this point, I can begin to add dimensions, specific dimensions that are going to define the sizes that I want this part to be able to be created in. And in order to do that, what I'm actually going to do is I'm going to come down to my model parameters, size parameters, and I'm actually going to come in and I'm going to look at my parameter configurations. Actually, we're going to go to parameter configurations. What you'll see here is you actually have all the different definitions of what we have defined. We have the diameter, one that we defined for our profile, which was a dimension. We also have our height and our width dimensions that we included. And this is going to help us define the different part sizes, if you will, that we're going to include in here. So we have some basic connection definitions. All of these parameters were created when we added those connections. And these, if I zoom in, I'm just going to close this for a second. If I zoom in, you'll notice that they're also defined here. D1 was, for example, the diameter. So you have access to all of that we're going to go through now in almost like a database of sorts that we're going to use. Now, the other thing that we actually want to do, I'm going to go back into my modeling, is we're going to start with what's called these model parameters. Okay? And if I edit my model parameters, this is going to give me what has actually been defined based on the way that I drew this. Okay? Values, a description of all of those parameters that I was just looking at that define this part. What I want to do is I actually want to set up some rules. And the first thing that I'm actually going to do is I want to define my length. And I just want to check here because I think I want to add one more dimension before I do this. Yep, let me go back. I just want to add just a few more dimensions because I want to, okay. What I want to do here is I have the connection dimensions, but I want to make sure that I also have dimensions for my distances for the length from the center line here of the connector, of the T to both the ends and to the length of the branch. So in order to do that, what I can do is I can actually come into my work planes. Remember, everything goes on the work plane that we were working on, and I can simply say I want to add a dimension. And in this case, I'm going to add a distance dimension. And my distance dimension that I want to add is actually going to go from this point to this point. I'm going to pick a location. And this is going to be my first length that I'm going to define. Now remember, these are my shoulder lengths, and all three of these shoulder lengths are going to be equal. And these lengths in here I want to define to make sure when I define my shoulder lengths that this transition is not happening inside of my T. Okay? So this is the first length I want to define. Then I also want to define a distance for my shoulder length. So I can come back into my XY plane, say add a dimension, and add a distance. And I have different ones I can use. I can use a horizontal, vertical, parallel, perpendicular. I can also put in diameters and angles if I wanted to create, an unusual dimension to hold the shape. Distance is the most common that I find most people tend to start with, and then the more complex the part gets, they begin to get into more of the other types of dimensions. In this case, I want to dimension my shoulder length, so I'm going to go from the end point to the second point. I'm going to select a location, and I'll put it down here just to keep it out of the way. That's going to be my length A2. You'll notice also that what happens is when my lengths dimensions get placed, it automatically defaults to begin to put some variable or parameter names around all these lengths. So you'll see that I have a length A1, I have a length A2. And I want to add one more in here, which is going to be my length between, for the branch, from the center of the T out to where we want that transition to end. And I can do the same thing by simply adding a dimension, which is a distance dimension, from the center point to there. And I'm just going to pull this one out here just to get it out of the way. Okay, so three basic dimensions that I want to make sure that when I define the size for this, that if it's an 8 by 8 or a 10 by 10 or a 10 by 12 or whatever it might be, these are the key dimensions that I'm going to need to define for that part. All right, so again, it takes us back to what are the dependencies on the part when you're beginning to create it. So that's basic dimensioning if you wanted to add additional dimensions after you had defined the shape. Any questions with that?
Nope, I don't think we have any right now, Laura.
Okay, so hopefully we're good and that made sense. So that is where we are with all the dimensions. Now, remember I had shown you here in our size parameters, if we go back and we look in we now have not only our connection size information, but we also have some basic geometry. We have some lengths that were also put in here as well. Okay? And what I want to do is I want to begin to now define those model parameters. And in order to define those model parameters, I can come into model parameters, and you'll see that what's here, and I'm trying to move this out of the way so you guys can see everything. Here's all my parameter names. All of the cyan color that's here are all my different dimensions. And there's a couple that I want to define, because what I want to define is I want to create the relationship that is going, or the rule that is going to maintain the proper proportions for these different dimensions that I've added to my part. And the way that I want to do that is the first one I want to change is going to be my length A3. And my length A3 was the distance from the center of my T out to out down the branch to where I want that transition to make sure that it's going to come. And what I can do is I can take advantage of what we have here as the calculator. And this calculator allows me to actually enter in a formula that will calculate that for me based on other dimensions or parameters inside this model. So in this case, what I'm going to do is I want to define this. D1 was my diameter of that part of the T. I want to take half of my diameter, and I want to add 2 to it. So it's going to be half my diameter plus 2 is the formula that I want to use to help shape this specific size. And again, a lot of this, it's very helpful to understand how parts are put together by looking at the manufacturer cut sheets. That's the first one that I want to do. The other one that I want to do is my length A1, which is the distance from the center down the length of the main trunk of the T. And in order to do that one, I can simply select on length A1. I'm going to go back to my calculator. I'm going to say that this is going to be the RHW, which remember was the our W3, which is the width of the rectangle. I'm going to take half of the width of my rectangle, which is half of the width of the branch. Okay, we're going to take half of that, and I'm going to add 2 to that. Okay, so now I have my length A1 and my length A3 defined. Again, maybe a little bit complicated. Very important that you understand how the dependencies of the different features inside your part, how the branch relates to the main trunk of this part. Manufacturer cut sheets are great for helping to explain that. So that is how I can actually go in and begin to assign some sizes to this part. Okay? And you'll notice I'm not changing my values yet because I have another trick that I'm going to show you when I get to that point. We're going to simply close this for now. You'll notice that my part stretches slightly because I built some rules around it to ensure that the proportions are maintained. All right? So the next thing that I want to do is we can actually come in, and one thing that I didn't show you, which is actually something very easy, when we added the connectors, what we can also do now that we're getting into kind of working with all the database, per se, that's behind this part, is when I expanded our connectors, you'll notice that what I did is I had 2 round connectors and a rectangular. One thing that I didn't assign to this was I have an undefined connection type. Well, I want to specify a specific connection type. And the quickest way to do that is I can edit my connections, and I can simply select from the different types of connectors that are available to me in building systems. And these are hard-coded based on what's in building systems. So as building systems continues to add in more specific types of parts, you'll probably begin to see this list get bigger with different types of connectors, connections that building systems will support. So I want to make sure all of those are slip joint. And that is it for connectors. And I meant to do that before and totally forgot. So hopefully that makes sense to everybody there for connectors. At this point, the last thing that I want to do is I want to get some values into this for sizing. I want to give this an entire group of sizing. And the best thing that I can do is get to know the different parts that are in my catalogs. And what I can do is I can actually select on Catalog Editor. And if I look at Catalog Editor and I go into the Duct US Imperial Catalog, I can look to see if there is a similar part that has all the different types of sizes I want, has all the different sizes of round duct, all the different sizes of rectangular duct. Maybe there's another T that might have been created that was something different. And in this case, I have a T that was created as a banded T, and there's one of the things that I can do is actually take a look, and if I look at the parts in Catalog Editor, what this is doing is it's breaking this up very similar to what we saw when we defined where this part was going to go in the catalog. I'm going to use banded, for example, and under banded I have T's, and I have a rectangular, round to rectangular transition T that's banded. I have a tap T, conical, all of these different ones that are in here. Maybe they have similar sizes, so I can simply, rather than having to going in and manually enter all the different sizes, I can come over and take a look at, here were the parameters that were defined, very similar to what we had. They have a one single diameter, because in this case, it's a rectangular with a round. So there was a height and a width for the rectangle, and there was a diameter for the round part. Look at the abundance of sizes, possibilities that I have. Now, I certainly don't want to go in and type all of those in as possible sizes for this part. So what I can very quickly do is I can do a cut and paste. I can simply select all of these using Control Copy and Control Paste, do a Control Copy, come back into where my model parameters were. We're going to go to Size Parameters. We're going to edit our configuration. First thing that you want to do is you'll notice that my D1 right now, my D1s and my heights and my widths, they're referred to as constants. with what's called this data storage. And this might look like a bunch of gobbledygook to everybody, but what this is doing is the parameter configuration. The configuration is what's defining the type of parameter that this is. And in this case, it's telling me that all of this particular one is a constant value. It's telling me that D2 is a calculation. Now D2, I changed to be a calculation because I want that to be a calculated value. Same with the height and the width of our rectangle, they're constants. If I double click on this data storage type, I can now say, you know what, I want a list of variables. And what I can do now that I define this as a list, I want to do the same thing for my height, my width, and also for my diameter. I want all these to be lists because I want to populate them with a list of different available sizes. Once I have that done, I can simply come up to the top of this and click on Values. And what this does is, again, this shows me what we were looking at before, which is my connection parameters, also my geometry parameters that I added in. And I can come into here and simply do, you'll notice that I don't have anything in here right now except for 10 inch, because that was the default size when I created this geometry. I can simply click on this, do a Control Paste, and now you'll see I have my entire list of all those sizes that were in here. I can do the same thing for the diameter and for my width, simply going back into Catalog Editor. I'm going to go up to the top of my RW, which is my width for this specific part. Do a Control Copy. Come back into here, click on my width parameter, do a Control Paste, and you'll see that I have a whole selection again of parts sizes. Okay, and I can do one more for my D1. That will keep me from having to type in all of this information. I can simply do Control Copy this selection. Let me try that one more time here. Do a Control Copy. Come back into my part. Come over to my D1. Do a Control Paste. And you'll see that it's all connected. Now you also notice that, remember, D2, when I define this, had a relationship that was equal to D1. Because if I look at my part, this was my connection for D1, this was my connection for D2. Both of those connectors were based off of my D1 profile dimension, which is why they both updated. With my model. And notice when I click on this, I'm getting model-based calculation parameters must be modified through model parameters. That is because I say OK here. If I go back into my model dimensions and model parameters, and I look at what's defined, you'll notice here that my D2 is equal to my D1. Okay, so that's how we begin to define all the sizes that are associated with this. Jason, did I lose anybody here yet?
I don't think anybody's lost, but
okay.
There have been a couple questions about whether or not they can, rather than starting from scratch with this new piece of content, whether they can take existing ABS content and modify it.
Absolutely. If you have a part that is similar to another part that's in there, you essentially would copy that part into another location inside your catalog, and then you can edit that part, make your changes, and move on from there. So absolutely, take advantage of the parts that are in there if there's something that's similar.
I would add one caveat.
Yep.
There is some of the parts in there are actually a different kind of file, which you can't actually edit using Content Builder, the TOM parts.
Yep. What you want to do is when you actually open up a part and when you're in the when you click on Content Builder for the first time, if it was a parametric part that was created, you'll see that it will allow you to modify that. So the best way to do that is to actually open up Content Builder, search through the beginning part, the front end of Content Builder, and navigate through the catalog, select on a part, see if it's actually something that can be parametrically modified. We have some legacy content that's in here that you will not be able to modify from that. So that's the best way to find out if it's parametric parts that were built with Content Builder. Anything else?
I think that's it for now.
Okay. And I know we're running a little bit late here, but I just want to get through the last couple pieces here. We now have the sizes that are associated to this part. And what I can do is, if I want to, now you'll notice that the only dimension that I haven't defined yet was this length over here, which was our shoulder length. Now, what I can do to edit that is I can come back into my model parameters. I can simply say Edit. I can come over to my length A2, and I can simply just add in that I want this to be 1 inch, and I can directly enter in values here if that's all I wanted as well. So a couple different ways that you can define your information. Okay, so you'll notice now that what it did is it gave me a set length of 1, so that all of my shoulder lengths are going to be defaulting to 1, and it automatically updated the model for me. All right. Now the last thing that I can do here is I'm actually going to save my part. And if I want to preview any of these different sizes, what I can do is I can come down to my size parameters. I can go into my Edit Values dialog box, this little dialog box that we've been working with, and I can actually begin to select some information and say, you know what, I really want to see if my part is going to work. So you know what, I'm going to select some information. I say I want my height to be 6 for my rectangle, I want my width to be 8 inches, and I want a diameter of, say, 5. And what that's going to do is define the information. It's going to work all the formulas or select any of the parameter information, the relationships I established, and I can actually use this preview part. Come in, I can preview my part. I get this parametric object viewer window. I can switch to an isometric view, and I can now look at my part that I created and say, is that exactly the type of part that I want? I can do that for every single size. So if I want to ensure and verify that every single size that I get created works and that it maintains the right shoulder length and all that information is there, I can take advantage of doing that right inside of the content builder. All right. Now the last couple things that I can do now that I'm all done, I've added my sizes, I've defined my shape, defined all the rules that need to apply for this parametric shape. I can also create a bitmap because remember this is stored in the catalog. I have a button up here called Generate Bitmap. I get this little dialog box that pops up, and I can say, you know, what's the bitmap that I want my my users to see? Oh, that looks like a good one. You know, and I can go through all of these and create a bitmap that will be stored in the catalog for whenever this part is going to be used. Simply say OK, find the bitmap. And the one other thing that I want to do here is I have options. Now, a lot of people go ahead and they build parts. And I built my part, I added it to my catalog, but when I do my auto layout, it's not available. It doesn't come up as a valid part. Very important to keep in mind. If you want this specific fitting, especially when you're working with a fitting, if you want this part to be automatically inserted during layout, you need to make sure that in the Options dialog box, and remember where I found that, it was right next, right up here on the end of these little icon bar, under Options, I want to make sure that I check Auto Layout Flag. Okay, this is going to allow this part to be seen during auto layout when you take advantage of that auto routing option. Okay, the other thing that you have in here is you also have Hide Part. If you're developing parts and you want these parts to not be seen, if you're a CAD manager and you're developing all these parts and you're kind of working on them, you're still testing them, you can say, you know what, hide the part. The part will still, the part will not show up in the catalog, but you can still get to it, you can still work with it, and you can still develop it, but you're not letting your users use it. So it's a way that you can actually save what you've done to up to this point and then continue moving on. In this case, this part's finished and we want to use it, so I won't have that checked. The other one in here is also for custom sizes. I defined a list of sizes that were available for this part. If you want a user to be able to enter in a part and take advantage of create any size that you want using this parametric model to build it, I can actually come in here and say, yep, go ahead. Let them enter in any size they want for the diameter or any size they want for the width and height of that rectangle branch. and they can and use the definition of this part to build it. All right. I'm going to leave that off for right now because I only want to use the specific part sizes that I defined. So that's what's in the last piece for options. I'm going to simply say, okay. Now you'll notice that I got one interesting thing that popped up. I got all these little circles. The last piece that you need to understand that when you're going to use auto layout, you need to define what's called trim lengths. And what trim lengths are is that if you've laid out a duct and you're connecting a branch, and that branch goes into that duct, the program, Autodesk Building Systems, needs to know how far back am I going to trim my duct in order to place this fitting. Okay? And what I do is I'll get a new folder over here. I'm going to minimize some of these so you can see this. I get a new folder over here called Auto Layout Data. Don't forget to create trim lengths if you are going to allow this to be automatically inserted during auto routing. I simply add a trim length. What I do is I come down. It's going to ask me for select start of trim length 1, and again by default I go from left to right, top to bottom for my trim lengths, just so I can remember what order I put them in. Doesn't really matter which way you do it. And I'm going to select the circles that appear at all these points. Now my first trim length is going to be from here to the center, from my end to the center of my T. My next trim length is going to be from the center out to this connector, and my third trim length would be from the center to the end of the branch. Okay, so I'm just going to quickly add those other two in here. You'll notice it highlighted my first one. My trim length will be here. Selected my other trim length. Great time to take advantage of turning off some of the visibility of things in here. I have a lot of cyan lines. I have a bunch of dimensions. What I can do is come into my dimensions, simply say, you know what, I can't see them because when I pick on things, it's picking something I don't necessarily want. So in this case, what I can do is simply say I don't want those visible. I'm going to come back into my layout. I'm going to say add a trim length. I'm going to come over here. I'm going to select my trim length, second trim length, and now I'm going to add my third trim length. Third trim length is going to be from the connector of the branch to the center. And now I have 3 trim lengths, so it knows exactly that it needs to cut back my duct this distance as well as this distance for the branch to insert this fitting. The last piece for this, for doing auto insertion, is you also need to select a placement point. What is that center point or placement point that you want that part to be? And in this case, my placement point is the center of my T. And you'll notice I get a second circle that appears. This circle is actually representing my trim lengths, and that's the placement point. Okay? And that, my friends, is the last step in this process. I can simply say, save my part family at this point. I have everything done. It will work for auto insert. I can do add fitting, and I can simply at this point say I want to close Content Builder. Everything is saved. I can come quickly over here, pull my tool palette in here. I can say add duct fitting. Wait for my dialog box to pop up. If I come into multi-shape under slip joint under T's, you'll see that here is my round to rectangular T example for the webcast. Here are all the different sizes that I can add in here. And you'll notice that I'm searching only for 100, and there's, 438,000 found. That is a combination of all the different sizes that I put into that could possibly be created based on what I just did for that one specific part. I can use my part filter. Here was the lists that I added. And if I want my diameter to be, say, 8, and I want my height to be 4, and my width to be 5, I found the part. I can come into my drawing. I can select a location, close out of this, take a look at this, and here's my part. And we are done. Zoom on my part, the whole thing. I can hover over top of it, and you'll see that it's going to recognize that it's a round to rectangular T example, which was the for webcast, which was the name that I gave it. And that's it. Any questions?
There was a question, Laura, on the ability. Some people noticed that your rectangular side was significantly bigger than the round side. They wanted to know if you could constrain it so the rectangular wasn't allowed to get, for instance, taller than the round.
Yes, you can. You absolutely can. You can constrain that so that it will stay in proportions if you want to. The other way you can also do that is when I added in my values, I used list for my values. I can also use table. And what table will allow me to do when I define the different part sizes, it will allow you to develop a table based on the available size options that you have. That's another way to do it if you don't want to put a physical constraint in, is you can use a table and lay out all your different part sizes based on that information in the database.